The input-output I/O section of a PLC is the section to which all field devices are connected and provides the interface between them and the CPU. Input-output arrangements are built into a fixed PLC, while modular types use external I/O modules that plug into the PLC. Figure 2.1 illustrates a rack-based I/O section made up of individual I/O modules. Input interface modules accept signals from the machine or process devices and convert them into signals that can be used by the controller. Output interface modules convert controller signals into external signals used to control the machine or process. A typical PLC has room for several I/O modules, allowing it to be customized for a particular application by selecting the appropriate modules. Each slot in the rack is capable of accommodating any type of I/0 module. The I/O system provides an interface between the hardwired components in the field and the CPU. The input interface allows status information regarding processes to be communicated to the CPU, and thus allows the CPU to communicate operating signals through the output interface to the process devices under its control. One benefit of a PLC system is the ability to locate the 1/0 modules near the field devices. Distributed 1/0 refers to inputs and outputs located at a machine and controlled remotely from the PLC, as illustrated in Figure 2.2. In order to minimize the amount of wiring required, the processor receives signals from the remote input modules and sends signals back to their output modules via the communication module. A rack is referred to as a remote rack when it is located away from the processor module to communicate with the processor. The remote rack uses a special communications network. Each remote rack requires a unique station number to distinguish one from another. The remote racks are linked to the local rack through a communications module. Cables connect the modules with each other. If fiber optic cable is used between the CPU and I/O rack, it is possible to operate I/O points from distances greater than 20 miles with no voltage drop. Coaxial cable will allow remote I/O to be installed at distances greater than 2 miles. Fiber optic cable will not pick up noise caused by adjacent high power lines or equipment normally found in an industrial environment. Coaxial cable is more susceptible to this type of noise. The PLC's memory system stores information about the status of all the inputs and outputs. To keep track of all this information, it uses a system called addressing. An address is a label or number that indicates where a certain